Hello everyone and welcome to your partner in education, Agile Rank Mate. Today, in this particular episode of VITEEE workshop, we're going to be looking at some sample questions that could be used as models for the VITEEE exam. In the VITEEE exam, we've got questions ranging from physics to chemistry to mathematics. So we'll be looking at some questions from all three of these topics, and we'll learn how to solve them effectively. So let's start up with our first question. This one is from physics. If the potential energy of a gas molecule is U equals m by r raised to 6 minus n by r raised to 12, m and n being positive constants, then the potential energy at equilibrium must be 0 nm squared by 4, mn squared by 4, m squared by 4n. So, how do we solve this question? Over here, the potential energy of a gas molecule is given, that this is the equation here. We're also told that m and n, the two quantities in the numerator, are positive constants. We need to find out the potential energy at equilibrium. Okay, so how do we solve this question? Well, potential energy, when differentiated, gives us force. So therefore, let us differentiate the entire equation for potential energy to get the equation for force. Fe is equal to minus of du by dr. Now this is equal to negative d by dr of the entire equation, which is m by r raised to 6 minus n by r raised to 12. Now, when you have anything of the form 1 by x raised to n, then according to the law of exponents, it's the same as x to the power of negative n. So negative exponent basically means that the entire quantity is in the denominator with a numerator of 1. So, basically we can rewrite the equation here again as minus d by dr of m r raised to minus 6 minus n r raised to minus 7, minus 12, sorry. So from here on out, let us take the differential to both these sides, to both these stages of the expression. So to do that, let's take negative outside, and since m is a constant, it's not differentiated. So m dr raised to minus 6 divided by dr minus, since inside the bracket is still a minus, you have n, which is a constant, is taken outside, dr raised to minus 12 divided by dr. Now, here's what you would need to know about differentiation. When you're differentiating something of the form d by dx of x raised to n, the right side of the equation would be n times x raised to n minus 1. So the exponent becomes its coefficient, and the x quantity would have an exponent of n minus 1, which is 1 lesser than the original exponent. So that's how differentiation's general formula works. So now that we know that, let's apply that on both quantities. So minus of, and inside the bracket you have m times, since it's r raised to minus 6, it'll be minus 6 r raised to minus 6 minus 1, which is minus 7. Similarly, you have n times minus 12 r raised to minus 13. So now that we have differentiated the two sides, let's work with the signs. So the minus outside the bracket still stays as it is. However, inside we now have minus 6m, and since it's r raised to minus 7, we can write that as 1 by r raised to 7. So the first term would be minus 6m divided by r raised to 7. Similarly, we have minus n times minus 12. So that in effect becomes plus 12 n, and r raised to minus 13 becomes 1 by r raised to 13. So, by the way, we're still finding the force. So we move on to the next page. What we're going to do is again work with the minus. Since we have a minus outside, we're going to multiply that to both terms. So right now, force would be equal to 6m divided by r raised to 7 minus 12n divided by r raised to 13. So the signs get changed because there's a minus 1 multiplied to both terms. So this is the formula for force. So this is what force looks like when the potential energy is m by r raised to 6 minus n by r raised to 7. So once we've done that, we need to find the potential energy at equilibrium. Now, for any condition of equilibrium, there is no external force that changes the condition of equilibrium. So basically, at equilibrium, force is equal to 0. We will apply that rule here. So basically, 6m by r raised to 7 minus 12n by r raised to 13 equals to 0. Now what that means is 6m divided by r raised to 7 is equal to 12n divided by r raised to 13. When we switch the terms, we will get r raised to 13 divided by r raised to 7. What we did is take r raised to 13 to the left and 6m to the right. So since r raised to 13 is in the denominator on the right hand side, it goes to the numerator. Similarly, 6m goes to the denominator on the right hand side. So r raised to 13 divided by r raised to 7 equals 12n divided by 6m. Now, in the law of exponents, a raised to m divided by a raised to n equals a raised to m minus n. So when we apply that, r raised to 13 minus 7 gives us r raised to 6, and 6 goes into 12 two times, so the right hand side becomes 2n over m. So this is our next value that we need to keep in mind. So we know the formula for force is 6m by r raised to 7 minus 12m by r raised to 13. Our original formula is m by r raised to 6 minus n by r raised to 12. And we know that r raised to 6 has a value of 2n over m at equilibrium. So since we know the value of r raised to 6 at equilibrium, we're going to use that to calculate potential energy at equilibrium. So let's write that as U equilibrium equals to m by r raised to 6 minus n by r raised to 12. This is the general formula. What we're going to do here is we're going to substitute 2n by m for r raised to 6. So basically we have m over 2n by m as the first term, and the second term is n divided by 2n by m, the whole square. So the first term, the m in the denominator of 2n by m goes to the numerator, so we get m squared over 2n as the first term. The second term, we have n. The entire thing gets squared, so we have 4n squared over m squared. The m squared is in the denominator, it goes up, so we get m squared and the n that's already there over the denominator now becomes 4n squared. So basically we can cancel this square and cancel the n on top. So we have m squared over 4n. So m squared by 2n over m squared by 4n. This is the same thing as 1 by 2 minus 1 by 4. which gives us a value of 1 by 4. So therefore, the final value would be m squared over 4n. So the potential energy at equilibrium is given in terms of m and n as m squared divided by 4n. And if you look at our options, you can see that option D turns out to be the right answer. So all we did was differentiated the formula for potential energy to get force, and we know that at equilibrium force is 0. So when we applied that, we got the value for r raised to 6, which we then substituted in the formula for potential energy of a gas molecule in order to get its potential energy at equilibrium as m squared over 4n. So that's how option D became the right answer. Next question. A table fan rotating at a speed of 2400 revolutions per minute is switched off, and the resulting variation of RPM with time is shown in the figure. We need to find out the total number of revolutions of the fan before it comes to rest. All right, so the vertical axis is RPM, revolutions per minute, and the horizontal axis is time in seconds. Now, time is usually measured in seconds. So within 24 seconds, it goes from 2400 RPM to an absolute standstill. So let's write 0 here as well, just so that we know what our graph looks like. So we have an RPM versus time graph. We need to find out the total number of revolutions. The total number of revolutions, now if you've studied, say, a velocity time graph, you would know that the area under a velocity time graph gives you the distance. So similarly, for angular velocity, if you have an RPM versus time graph, the area under the curve would give you the total revolutions. And so all we have to do is find out area of graph, area under graph. So if you look at it from here, you have a triangle, a square, and another triangle. So these three figures together gives us the area under the graph. So we have area of, let's assign points, A, B, C, D, E, and F. So area of triangle ABC plus area of square BCED plus area of triangle CEF. So now we know which of these areas we need to calculate in order to get our answer, which is the total revolutions. So let's calculate them here. So area under graph. Now the first thing we need to find is area of triangle ABC. Now area of a triangle is half base times height. Now over here the base is BC, which is 8 from 0. So the quantity here is from 0 to 8. So 8 minus 0 is still 8. Now remember that 8 seconds, 8 is the time given in seconds. So therefore we would have to divide that by 60, because we know that our angular velocity is given in revolutions per minute. And the RPM is from 600 to 2400, so 2400 minus 600, that is equal to 1800. So that's our first area. Now if we look at the second area, this here is the area of a rectangle, by the way, not a square. So because on one hand it's 600 and on the other hand it's 8 by 60, so it's not a square, it's a rectangle. So so again, length times breadth. So the length would be 0 to 8 again, so 8 by 60, and the breadth is 600, so we would multiply those. So 600 times 8 over 60. Now, the third area is area of triangle CEF. Now in CEF, the height is from 0 to 600. This line is corresponding from 0 to 600, so the height would be 600. And the base, which is time, would be from 8 to 24, which is 24 minus 8. That would give us 16 seconds. So we have to convert that into minutes. So 16, divide that with 60. All right. So this is how the area would look like. Now, 2 goes into 8 4 times. We can cancel out a 0. 6 goes into 18 3 times. So it goes under 180 30 times. Similarly, we can cancel out a 0. 6 goes into 60 10 times. And finally, 2 goes into 16 8 times. We can cut out a 0. 6 goes into 60 10 times. So basically what we get is 4 times 30 plus 10 times 8 plus 10 times 8. So that means we can now 30 times 4 gives you 120, and 10 times 8 gives you 80. So it's basically simple arithmetic, 120 plus 80, which again at the end gives you 280 as the solution. And since we're counting total revolutions, the total revolutions from 2400 RPM to 0 RPM is 280 revolutions. So if we look at our options, you can see that option B, 280, is the right answer. So what we did was, we understood that this was an RPM versus time graph, and we need to find total revolutions. So all we had to do was calculate the area. We used mensuration. We also had to take note of the fact that the time was given in seconds, so we had to convert that into minutes. The rest of it is simple arithmetic, and we got the answer as 280 revolutions. Now let's look at some questions of chemistry. Phenol is heated with phthalic anhydride in the presence of concentrated H2SO4. The product that we get gives pink color with alkali. We need to find out what the product is. Straightforward question. The second line gives it away. Pink color with alkali is an indicator. So since it gives pink color with alkali, it can be used as an indicator, and the indicator in question is option A, phenolphthalein. So option A turns out to be the right option. Option B, bakelite, is a plastic. Salicylic acid is an aldehyde, is a carboxylic acid, and fluorescein is a pigment, but it is not done with in the presence of phenol and phthalic anhydride. Again, if you look at phenolphthalein, it's got the components phenol and phthal. So that also gives it away. So option A, phenolphthalein, is the right answer. It's an indicator that we use to find out whether the given substance is a base or not. If it gives pink color with alkali, so therefore it can be used as an indicator. It's a synthetic indicator. Right, next question from chemistry. NH4Cl, ammonium chloride, is heated in a test tube. Its vapors are brought in contact with red litmus paper. The vapors change the litmus paper to blue and then back to red again. This is because of formation of NH4OH and HCl, formation of NH3 and HCl, greater diffusion of NH3 than HCl, greater diffusion of HCl than NH3. So if you were to heat ammonium chloride, then we form hydrogen chloride, HCl, and the remainder is NH3. So again, law of conservation of masses helps us to get the products here. So we know that it is the formation of NH3 and HCl, not NH4OH and HCl, so option A is incorrect. But is option B correct? We know that ammonia is basic and hydrochloric acid is acidic, but if we look at the question, the vapors that are brought into contact with red litmus paper changes it to blue first, and then to red. So, how does this work? So, HCl is acidic, turns blue litmus paper to red, and NH3 is base, so red litmus paper turns to blue. Now, our sequence of color changes from red to blue and then to red. So red to blue is caused by NH3, but then after some time we notice that the blue changes back to red, and that is because of HCl. Now why does NH3 does not stay? Now why does this happen? This is because after some time NH3 diffuses away. Now we're talking about vapors obviously, so diffusion happens for all vapors. However, certain vapors diffuse faster than others, and if it's the case that the HCl is manages to turn blue litmus paper to red, which was turned blue in the first place by NH3, then we are pretty sure that NH3 is diffusing faster. And since that happened, then the particular scenario happens. So therefore, greater diffusion of NH3 than HCl is the reason why vapors of ammonium chloride changes red litmus paper to blue and then back to red. So therefore, option C turns out to be the right option. So since the persisting vapor is HCl, turns the red litmus paper from blue back to red. So therefore, NH3 has gone from the equation. That means it's diffused faster. So option C is the right option. Now, let's look at some questions from mathematics. If n denotes the set of all natural numbers and R be the relation on natural numbers defined by AB related to CD, if AD times B plus C is BC times A plus D, then R is symmetric only, reflexive only, transitive only, and equivalence relation. Let's define the three terms. So reflexive means A comma B can form a relation with itself. Symmetric basically means if AB can form a relation with CD, then CD can form a relation with AB. Okay? And finally, transitive would be the case where if you have AB related to CD and CD is related to EF, then AB will also be related to EF. So these are any, this is a generalization of any, relation. So we're looking at the scenario where these statements are true for everything. Now, if, say, an equation is reflexive, symmetric, and transitive, then it's called an equivalence relation. Now, the relation is A comma B is related to C comma D if AD times B plus C is BC times A plus D. So this is our relation. Now let's test for reflexivity. Okay, so basically A comma B related to A comma B. So that would mean AB times B plus A equals BA times A plus B. Now, this generalization is true because of commutative property. Now, we have commutative property for multiplication and addition. So therefore, if you were to multiply both sides, you would get AB squared plus A squared B. So you can try doing that. So you get AB squared plus A squared B here, and you would get BA squared plus B squared A. So they are still equal. So therefore, the relation R is reflexive. So now we know that it's reflexive. You might be tempted to check B only as the answer. However, we've got two other tests to work on. So let's look at symmetry. Right, so we have R is a relation from AB and CD. So AB and CD are related with the relation R. Now that means AD times B plus C equals BC times A plus D, right? Now let's say we had the opposite relation. So we had CD related to AB. Okay, so that would mean CB times A plus D equals DA times C plus B. Now if you look at it, both terms, so this term is the same as this term is the same as this term. We can prove that by multiplying. So basically, again, commutative property ensures that all four sides are the same. So if you were to do that, we can know that it's ADB plus ADC equals BCA plus BCD, and the second equation would be CBA plus CBD is equal to DAC plus DAB. So again, commutative property would mean that all four of these are equal to each other. So therefore, that would mean that R is symmetric. Okay? Now let's check for whether R is transitive or not. Now you could skip that. So since we know that it's both symmetric and reflexive, we know that all three of these options would be incorrect, because A says symmetric only, but we know that R is reflexive. B says reflexive only, but we know that R is symmetric. C says transitive only, but we know that R is both reflexive and symmetric. So we're pretty sure that option D is the correct answer. So R turns out to be an equivalence relation. So basically, if you have to check for transitiveness, AB related to CD means that AD times B plus C gives BC times A plus D. Now the second relation here would be CD related to EF. Now that gives us CF times D plus E equals DE times C plus F. All right, so over here we would have to multiply them. So let's categorize them as 1 and 2 for the sake of simplification. So 1 becomes ADB plus ADC equals BCA plus BCD. 2 becomes CFD plus CFE equals DEC plus DEF. Now if you look at 1, we can rearrange the terms to get ADC minus BCD, and the other side would be equal to BCA minus ADB. And for 2, we will get CFE minus DEF as equal to DEC minus CFD. All right, so 1 now becomes A times, let's see if we've got another page. We don't. So basically we get A minus B times CD equals C minus D times AB, and that can be rewritten as AB over A minus B equals CD over C minus D. Now similarly, we can write this as, we can take EF common, so you get C minus D. The right hand side would be CD is common, you would get E minus F. So therefore what we get here would be CD over C minus D equals EF over E minus F. Now we know that CD by C minus D is common on both equations, so therefore what we get finally would be AB over A minus B equals EF over E minus F. This is sufficient proof that R is transitive. So we know that R is symmetric, we know that R is reflexive, we know that R is transitive, so therefore R is now an equivalence relation. So since it's all three of them, we know that R is an equivalence relation. We didn't have to do the transitive bit because we know that if it's symmetric and reflexive, then we know that the other three options turn out to be incorrect. So option D, R is an equivalence relation, turns out to be the right option. Now let's look at the final question. Final question goes, if modulus of x squared minus x minus 6 is x plus 2, we need to find the values of x. Now the values, if this is what the modulus equation is, then basically we would have two cases. A case where the value of the modulus is less than 0, and another case where the value of the modulus is greater than 0. When it's less than 0, it's negative times the value on the right hand side. When it's positive, it'll be plus positive times the right hand side. So so now we know that the two cases symbols are, we can use them to find out the values of x. So our first scenario would be when x squared minus x minus 6 is less than 0. Now when this happens, our equation would be x squared minus x minus 6 would be equal to negative of x plus negative of 2, so that's minus x minus 2. So let's try to find out the two cases where it's the limits of this particular modulus function. So in order to do that, let's take this quantity over here, x squared minus x minus 6 is less than 0, and then factorize it. So we have 6, so we can use 3 and 2 in order to get a negative x. So x squared plus 3, we can use minus instead of plus, so we can use minus 3x plus 2x minus 6 is less than 0, not equal to, we have to use the same symbol, so less than 0. So basically we can factorize that as we'll get x and 3 together, so x minus 3 is one factor, the other factor would be x plus 2 would be less than 0. So from here we know that x minus 3 is less than 0, so therefore x would be less than 3. X plus 2 is less than 0, then if it goes to the right hand side it becomes negative 2. So therefore x should be greater than minus 2. So basically what that leads is that the limits of this particular case would be minus 2 less than x less than 3 for the modulus function given. Now, we know that x squared minus x minus 6 when it's less than 0 is minus of x plus 2. We'll just apply that here again. So x squared minus x minus 6 equals to minus x plus 2, which is minus x minus 2. We can take the terms on the right hand side to the left hand side. So we get x squared minus x plus x. And then we have minus 6 minus 2. Actually it's minus 6 plus 2. So therefore, the right hand side would be 0. The x's cancel each other out. So we have x squared minus 4 equals 0. That means x squared equals 4. And x would be equal to plus or minus 2. So we get two solutions. We need to find out if those two solutions subscribe to the limit. Now the limit here says that minus 2 is less than x, less than 3. So x equals 2 lies in this domain. All right, so we have two values here, x equals plus 2, x equals minus 2. X equals minus 2 is not correct for for the modulus function less than 0 because we don't have an equal to. It's not less than equal to. It's an exclusive interval. So therefore, x equals plus 2 is the only solution when modulus of x squared minus x minus 6 is less than 0. All right. So let's look at the other case when x squared minus x minus 6 is greater than 0. All right. So the equation that we would be using here would be x squared minus x minus 6 would be equal to x plus 2 itself. So it'll be like how we got in the question. Because since it's on the positive side, therefore there is no negative sign involved, so the right-hand side stays the same. Now, when we try solving for this, we don't have to do all of these steps because we know we've done them here already. So we know that x plus x minus 3 times x plus 2 is greater than or equal to 0. Now that would give us x as greater than or equal to 3 or x as less than or equal to minus 2. So our interval is basically x should be greater than 3 or x should be less than x should be greater than or equal to 3 or x should be less than or equal to minus 2. So basically all of the real number line except the interval for the first case. Now at x squared minus x minus 6 equals 0, the right hand side x plus 2 is also equal to 0, which is also equal to the left hand side, which is x squared minus x minus 6. We need to write it in this format so that we can get x plus 2 to the left hand side. So we get x squared minus 2x minus 8 as equal to 0, simple arithmetic. Now the left hand side is, let's just pull it over here. So the left hand side now becomes x squared. Now we have 8 as the constant. We need to write negative 2x as equal to negative 8. So we can use plus 4x minus plus 2x minus 4x. That would give us minus 2 when added, and when multiplied that gives us minus 8 equals 0. So you have x plus 2 and the other term would be x minus 4 as equal to 0. So if x plus 2 is equal to 0, then x equals minus 2, and if x minus 4 is equal to 0, then x equals 4. Now minus 2. Now we know that for our second scenario, x can be less than or equal to minus 2, so therefore this solution holds, and x equals 4 also holds because it's greater than 3. So therefore, the solutions to the modulus function, let's write that in the final page, the solutions to modulus of x squared minus x minus 6 equals x plus 2 are plus 2, minus 2, and 4. Now, if we look at our options, you can see that option D is incorrect because it's got 4, 4, and 3. Option C is incorrect because it says 3, 2, and minus 2. Option A is incorrect because it says minus 2, 2, and minus 4. Remember, we got positive 4. So therefore, option B, minus 2, 2, and 4 turns out to be the right option. Now, that concludes this episode of VITEEE Workshop. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to Agile Rank Mate, your partner in education. If you want to get the latest updates from our channel, then please don't forget to hit the bell icon present below the video. So until the next episode, take care, stay alert, bye-bye for now.